Hello guys, welcome in this video. In this video we are going to start a new example of creating custom forces in Houdini to derive the simulations. By custom forces we mean a field or a custom velocity field that drives the simulation as we did with the Maelstrom or the ocean vortex example. So what the curve force does is that it pushes the simulation, for example, the smoke simulation, along a curve. So what we do is that we create a curve, for example, okay, and what we are going to do is that we are going to create three forces that deal with this curve. We are going to create a force that pushes the smoke along the curve, so our smoke follows our curve, and we are going to create another force that makes our smoke push towards the curve because we need our smoke to be adhered to our curve, okay? And another force that makes our smoke twist around our curve here. So it's going to twist like this. And surely we are going to create controls for these three forces, okay? So we are going to create a suction force that is going to push the simulation towards our curve, and a follow force to make the smoke move along the curve, and the orbit or twisting force to make the smoke twist around our curve. Actually, in Houdini, there is a node called the gas curve force, and it does roughly the same thing here, but I don't like it, okay, because I don't have the results that I want, okay. And of course, guys, it's better to create nodes and know how they work as we did before. It's going to open your eyes and broaden your mind in Houdini and makes you able to create more custom things that fit your situation. So this gas curve force is available, and we are going to create our example. And actually our example is going to be there is going to be differences between our example or our created curve force or the version that we are going to create. And there will be differences between the version that we are going to create and the gas curve force. Surely we are not going to create the same thing, we are going to make it with some difference. So now what we are going to do is that we are going to create a curve first. Just draw a curve. And then we are going to resample this curve. We're going to create points along this curve. Okay. And we are going to use a node called polyframe to generate tangential vector along this curve. So this polyframe node generates, I'm going to choose a different color. It generates a tangential vector along the curve. So the tangential vectors are going to look like this from upwards, downwards along our curve. And we are going to set these vectors as the normals. Okay, so these are going to be our normals. We are going to create normals that are tangential to our curve like this. And what we are going to do next is that we are going to create a volume, okay, with the same bounds of this curve. So we are going to have the bounds or the boundaries of the curve like this, and going to make a volume with these boundaries, okay. Surely a volume is full of voxels, or is composed of voxels, as we said before. Then we are going to do all the magic inside a volume VOP node. And the volume VOP node, I think this is the first time we are using it. It's like the same, it's like it's just the same as any VOP, okay, but it deals with volumes. It's more like the gas field VOP, where we dealt with the volumes or fields. We accessed our different fields and did a lot of things with them. So we are going just to create this volume VOP, okay, and this volume VOP has 4 inputs. We are going to connect our volume to the first input, and we are going to connect our curve points to the second input, okay. So now we can deal with our volume that we are going to call our velocity volume, or the velocity field, okay. Then what we are going to do inside this volume VOP is that we are going to use something called point clouds. And this surely needs more explanation, because this is the first time we use the point clouds, and they are very, very useful, and we are going to use them a lot. So what a point cloud does: the point cloud is a node called point cloud open, and this node just takes the position, okay, and take another geometry that you want to search into. So for example, you can give it the position of some points, okay. If you have just the points of, for example, particles just flowing into just a simulation of particles like this, and for example, these particles are going to reach an object, and this object surely has points, or is composed of points. So if you connect the points or the particles to the first input, or sorry, if you connect the particles or the particle position into this position of the point cloud open, and connect your geometry here to the geometry input, what you are going to do is that you are going to search around these points in a specific radius. So if you set the radius, for example, to 1, the point cloud open is going to search for something around this point with the radius of 1 meter. So here you have the radius of 1 meter. You can set it to, for example, 3. It's going to be a bigger circle like this. So it's just searching around the points that you give the position of, and you are searching into this geometry that you are inputting here. So for example, if the point here, if this particle here, let me select this particle, if we are searching here in a radius like this, for example, and this radius finds this point here of this geometry, or it may find 3 or 4 or 10 points, you can set the maximum number of points that it finds. Okay, now after you found these points, you can grab things from them, or you can manipulate them in a lot of ways. So there are a lot of point cloud nodes, but we are going to use a node called PC filter. And this node grabs the specific, just grabs specific attributes from the found points. So if it finds, for example, 1 point, and we want, for example, the normals or the color, for example, from this point, or any other attribute, it is going to grab it. Okay, but if it finds, for example, 3 points, and the 3 points have different values of normals, for example, it's going to grab the average of the points. So it's going to grab the average normal or the average color or whatever you choose. So this is what a point cloud does. Surely we have a lot of point cloud nodes, okay, but this is the node that we are going to use, and we are going to use another node called point cloud num found. This node just returns the number of points that this point cloud open finds. Okay, so we are going to use it. So let's return to our volume VOP. What we are going to do in this curve force example is that we are going to input the position of the voxels of our volume into this point cloud. Okay, so here have the position of these voxels, and we are going to input our curve as the geometry. So our curve is going to be our geometry that we are searching into. And we are going surely to choose a search radius, for example, of 1. So we here have our voxels. We're going to use the same color, our voxels, and we are going to do a search radius. We are going to use the point cloud to find the normals of the curve within a search radius. So for example, we are going to use a search radius of 1. So in the voxels that are located 1 meter from this curve, for example, if a voxel is here and the distance between it and the curve is within 1 meter, so it's 1 meter or less, okay, to the curve, it's going to find specific points near it from the curve, and we are going to grab our normals of these points. So now we have our voxels that are near to the curve depending on the search radius, and we grabbed the normals of the curve which are tangential to these voxels. So we have now our normals. Okay, now what we are going to do is that we are going to negate these normals. So these normals are just tangential to our curve, but they are upside down. We are going to negate or just have the opposite direction of these normals. So the opposite direction is just downwards, upwards, and they are going to be tangential to our curve. Okay, so now we have vectors that follow vectors that follow our curve. So in the voxels here near to our curve, let me draw it here. in the voxels here near our curve, we are going to, let me draw it here. If we draw our curve here, a bigger version of it, in the voxels near our curve, or covering our curve within a search radius of 1 meter, for example, we will have vectors that are following our curve. So voila, here you have now your follow force. So this is the first thing that we are going to do. We are going to use the point clouds to search for the normals, and we're going to negate them to have our follow force. And this is our first force. Now after we already edited or modified our velocity volume inside our volume valve to have the follow force, okay, we are also going to do something to generate our suction force vectors. With the point clouds, we can grab the position of the points on the curve. Okay, so for example, if we have a voxel here, okay, and the point cloud finds this point, okay, and you grab the position of this point that you found. The position is an attribute that you can grab with the point cloud filter node. If you now subtract the position of this point, that you found by the point cloud minus the position of your voxel, what you are going to have is a vector coming from this voxel to this point. And we did the subtraction process a lot. So if you do this with all the voxels within the search radius of 1, for example, you are going to have in these voxels vectors that look from the voxels towards your curve. And surely these vectors are going to represent our suction force that is going to attract our smoke, for example, to our curve. This is our suction force. So now we have two forces. The third thing that we are going to do is that we are going to take these vectors that look towards our curve, okay? So we are going to take the subtraction process here, or the vectors that are that resulted from the subtraction process, and we are going to do a cross product between them and our normals, okay, and our normals that are tangential, okay, so our tangential normals. So to be able to draw this, let me just extend my curve here. If we take the cross product between a vector looking like this and a vector like this towards our curve, the resulting vector perpendicular to them is going to be a vector that is tangential to both of them, like And of course, I can't, draw this in 2D here. But if you have your curve and, for example, you take the direction, this tangential vector here, and you do a cross product between it and the vector that makes or for that makes or sucks the vector that attracts your simulation to the curve, the resulting vector is going to be perpendicular to both of them. So this vector, okay, if you see here, is just a vector that is going to push your simulation in this way. So it's going to generate vectors that are going to be twisted around our simulation. Of course, it's very hard to draw it here in 2D, but the result is going to be very, very clear and apparent in Houdini. So now you have your twisting force. Okay. This is the general idea that we are going to do in our simulation. We are going to generate our three forces. We are going to add them together and export them as our velocity volume.